what's up guys? I'm Matt Gary, and in this fourth episode of our Separation of Concerns and Apex Common tutorial series, we're going to go over the fflib application class, what it does, why it's important, and how you can use it. Alright guys, so welcome to the fourth episode of this Separation of Concerns and Apex Common tutorial series that I am putting together to hopefully make both of these things a little easier to implement in your Salesforce org, and a little less confusing as well. Hopefully, I don't know. Some people think these make things easier, some people don't think they work at all, but you get to figure that out for yourself, I guess, if you're here. All right, anyway. So the fflib application class, what is this? Why do we care about it? And, where does it fit into the Apex Common library? So this is really the first episode in this series that focuses directly on the code in the Apex Common library. And I really wanted to add this to the series primarily because the Apex Common library is, like I said in the second episode, probably the best foundation you can have to implement separation of concerns in your org. But also because there's not a lot of documentation, unfortunately, on all of the classes and their methods and how to leverage them in the Apex Common repo or really anywhere else on the internet. You're just kind of expected to learn it for yourself, and while that's wonderful, I guess, everything kind of needs a guide. So it's kind of a shame that there's not like a real one in existence aside from Andrew Fawcett's book, which is very informative but hard to read. Anyway, okay, so let's go over this fflib application class because it's very important. If you decide that you want to use the Apex Common framework, or library rather, this application class is kind of like the backbone to it all. I say that you don't actually necessarily have to use this, but it's really in your best interest to do so. It makes it easier to use mocking in unit tests. It also makes it so that your code has a lot more flexibility for future permutations of it. All right, so let's go over it, figure out what it is, all that kind of stuff. So basically the fflib application class allows you to use the factory pattern, which we went over in the last episode if you haven't watched it. And it does that by implementing these, or rather, creating these different factories for your different layers inside this application class. So inside the fflib application class, you have a unit of work factory class, and you can see this is a class. It's not a method, it's a class that has a bunch of methods within it. And there's also a public inner class for a service factory. Also one for the selector layer. And there's also a factory class in here for the domain layer. So you can see there's a factory for every layer, which is important because chances are, whether you know it or not, at some point in the future, it will be beneficial to you to, basically be able to leverage the factory pattern to make your code a lot more flexible. So, how exactly does the fflib application class work? How do we set it up basically so that we can use it for our needs for our specific Salesforce instance? Well, the first thing you'll need to set up is this application class, and we'll just set up a new one together. So it's maybe less confusing. I'll just pull this one off over to the side to make sure I can reference it and don't say anything crazy or real dumb while I build this. Because you never know. I might. Alright, so normally what you call this is, you normally call this class that you're going to create to leverage the power of the fflib application class application. Or if you have a bunch of kind of modular applications in your org, say for instance you have like a whole opportunity quote whatever application in your org, you might make it something like I don't know, sales application, right? Because on the other hand, you might have in your org a whole service application or something, right? There might be a whole service division that has their own code that you care about. There might be a whole sales cloud aspect that has code that only they care about. And sometimes it's beneficial to break those into two separate applications. But for our purposes, we're just going to call this application, and I'm going to put 2 on this because I just, like you just saw, I've already made a regular application class for this org. So, okie dokie, there we go. Let's figure out how to use this. So we've got this application class, and we want to create the factories for our different layers. Even though it's not technically a layer, it really kind of is. It kind of fits into the database layer, which is the unit of work. We'll want a unit of work factory, a selector layer factory, service layer factory, and a domain layer factory. Okay? And again, the reason that you want to do this is because even if you can't see it right now, you might not be able to, especially if your org is brand new. Even if you can't see it right now, this will make your code a lot more flexible for future implementations of it. There is a lot of power in using the factory pattern in this fflib application class. So even if you can't see it at this moment in time, it's not like a lot of overhead necessarily to implement this. So try and put this in place as early as you can, because it's going to be hard to go back in time later when you figure out, oh, maybe I do need this. If your Salesforce instance continues to grow, you probably will. So again, let's get back to it. So we want to create a factory basically for each of our layers in our org. Our unit of work, service, selector, domain. So basically what we do is we create 4 variables that basically represent those layers, right? So we'll do a public static final unit of work. Oh, actually I need to declare the type. fflib underscore application dot unit of work factory. And if you've never seen this IDE that I'm in, it's called IntelliJ, and I'm using the Illuminated Cloud 2 plugin. I've got a tutorial showing you how to set it up, so I'll link it in the description. You can go check it out. Alright, so public static final fflib application unit of work factory, and we'll call this the unit of work, and make this equal to a new fflib application dot unit of work factory. Now, this method here, unit of work factory, takes in a list of object types. So in the fflib application class, the unit of work factories, really I said method, but I mean constructor. The unit of work factories constructor takes in a list of S object types. And that's important. So we're going to need to create a new list of object type and pass it in a bunch of object types. Now, it's important the order that you pass in these object types. And the reason it's important is because that's basically their order of insertion. So if you need to create, typically you need to create an account before you create a contact. You create a contact before you create, I don't know, a case maybe. They need to be in order of insertion or update or whatever. So you would say something like account.sObjectType contact.sObjectType case.sObjectType. And my dog's up there just barking away. And once you've got these all in the correct order, you're good to go. And in another class, you can initialize this unit of work. Now, you might be thinking, real quick, you might be thinking, oh, okay, well, that's cool that I can do this, but what if I need a different order here from time to time? There's a way to deal with that, and we'll go over that later. So, actually, we can just take a look at it now. In here, there is a new instance method that we'll go over in a bit that allows you to send in a new list of object types so that you can change the order of those object types, on a whim, basically. If this order doesn't work for you in certain scenarios, you can always change it up. So don't worry, there's lots of flexibility there. Don't freak out yet. The next thing that we'll want to do is create our application factory, our service factory. So we'll create another public static final fflib application.service factory. And we'll just call this service. Call this new fflib application service factory. All right, now let's go see what the service factory constructor expects of us. It expects us to pass in a map of type to be able to create new instances of things appropriately. So what does that mean? We don't, at least in the context of this video, we haven't created any task classes, right? Or service classes. But ideally, what we would do, I've got some examples set up. I don't want to build a whole service layer class in this video. But basically, you've got, what you'll end up making is this task basically a service implementation class and a service interface for each of your services in your org, right? And what you'll end up doing is in your application factory, once you have this set up, and we'll go over the service class setup aspect of this in a different video. But basically what you'll end up doing is you'll say new map type, and effectively what you'll end up doing is saying task service interface maps to class maps to task service impl dot class. And so what this allows you to do is call this or reference this variable, call the new instance method for your service factory, this guy right here, and pass it a service interface type to get your service implementation class, right? So let me zoom in on this a little bit. I've been doing this without being zoomed. Not great. So this allows you to pass your task service interface in and receive your implementation class. And whenever we go over the service layer, we'll see how this is useful. This is a little less obvious for, it's a little less obvious usage-wise when you look at this at first, but when we go over the service layer aspect of this later, we'll go over how you can really, benefit from this if you want to or need to. All right, the next one that we're going to do is the public static final fflib application dot selector factory, and we'll call this selector, this variable selector, and we'll make it a new instance of, yet again, fflib application dot selector factory. And yet again, let's go check out what the fflib application's selector factory inner class constructor requires us to pass it. So it's looking for an SObject type to a class type to map to be sent to the constructor so that it can dynamically generate classes based on the SObject type that you pass to it. So let's set that up. We'll say new map SObject type to type, and then we'll basically set up the same kind of thing. So I've got a couple of selectors pre-built for us, and we'll go over this a little bit in a minute as well. So we've got case selector dot class. So basically what this will allow you to do is by calling this variable or referencing this variable and calling the new instance for the selector factory, you can pass in the SObject type and it will return to you this case selector class, which is this guy here, a selector layer class that I have built prior to recording this to make this all a little bit easier, maybe. Okay, the last thing that we need here is our final layer, which is our domain layer. So we'll create one last variable that is of the fflib application's inner class domain factory, and let's just check out for the last time what the domain factory constructor requires of us. And it requires us to send in a selector factory and a map of SObject type to type. So SObject type to class type. So we'll go on ahead and send in our selector factory, which is our selector, this guy right here that we just made, that bad boy. And I'm so sorry. I don't know why I said that. And then we'll create our map and take it from there. So what we'll end up with is apparently something this doesn't like. It'll go away. We'll say case.SObject type will map to the cases.type, or class rather. And that should be it. Unless I really did mess something up. But I don't think I did. Oh, that's why it's probably crying. Vacation to dot selector. And Yeah. Oh, one other thing. No, I did that. New map SObject type to type. This should be constructor dot class though. All right, and we should be able to save this, and hopefully it'll save, or it'll tell me why I'm crazy. It's telling me that constructor not defined. What have I done? fflib application domain factory application 2.selector. All right, we've got our selector in there. You got a new map of SObject. Oh, that's all it is. Should be SObject type. That's important. Okay. There we go. Now that's saved. Okay, cool. So we have set up now our application factory, basically, that will allow us to call these, these variables within it and initialize new versions or new instances of these classes that we've mapped here. So the important thing to note here is that this is kind of your hub to go to update a lot of things in the future. So say, for instance, eventually you need to start creating tasks. Then you'd want to come back in here and for your unit of work factory, do SObject, add the task SObject type. Or maybe you need to start inserting opportunities at some point. You're going to have to come back in here and add that to your unit of work factory, or else if you use your unit of work anyway to insert things, and we're going to go over the unit of work a whole bunch in the next section. So don't freak out if you don't know what this is. I'm going to go over all these things. So if you're confused on any of these layers, please, don't worry about it too much. We're going to go over each one of them as time goes on through these tutorial videos. So, anyway, you'll have to go update things as your application evolves. So, if you had a new service class, you'd go back in here and, add another mapping for the service class. Maybe it's like opportunity, or more generic, like sales service class maps to. It would be sales service interface maps to sales service impl.class. So every time you create a new service for this application, then you're going to come back in here and add that to the map. Same kind of thing here. So for instance, I have another selector called or for the contact object, so I could do contact SObject type maps to contact selector.class. And same thing for domain. Every single time that you create a new domain for an object, you're going to want to come back in here and create the mapping for it. So I've also got a contacts domain class. Okie dokie. And that's really it. And then basically, so I'm going to delete this because that doesn't actually exist. So basically, every single time you add some new functionality, you're going to need to come back in here and, add these mappings. And the reason that you need to add these mappings is because if you go over again to the fflib application class, every single one of these has this new instance method, or a variety of new instance methods. And more or less what happens in these, you don't have to worry about this too much. But more or less what happens in these, let's go up to the easiest one to kind of look at, is we get returned to us a new instance of the class that we've mapped. So for instance, this is the selector factory's new instance method, where I can pass in an SObject type, and based on that SObject type, I will get returned a class, right? I'm going to get the class type from this map that I've created. So let's bring these closer together. I've got this selector. I've created this, this selector factory. I've created this new map that I have passed to it. And in the map, I'm saying if I pass an SObject type of case to it, I need you to return to me the case selector class. Same thing if I pass you a contact object type, I need you to return to me a contact selector class. And back here in the new instance method, I pass it an SObject type, and then from this map right here, which we can look up here, is a protected map of SObject type to class type. Basically what we're saying is, let's get the class for the SObject type that was passed to me and return a new instance of that class to, you know, whoever's calling this method, right? And that's super important because that's where most of the power resides, right? You can just pass in, like, you know, an SObject type to a generic method that you create in like a service layer or something, and have it, you know, dynamically generate selector classes or domain classes, you know, at runtime for you. So you can create really generic code, especially for your service layers, that you know, allows it to be really, really flexible and determine, you know, how it should run, how that service layer method should run at the time it's running, not ahead of time. Anyway, so we've got these things set up. So how would we actually use them? How do we actually use these in context of our code, right? So I've got this task service implementation class that I just want to go over, and it's using the application class that we didn't just build together, an application class that I made quite a while back now. But basically, it's using this application class, and this is virtually the same as what we just built. But it's using this class to create new instances of our selector, our domain, our unit of work, all that kind of stuff. So let's just kind of walk through this and see how it works. So I've got this task service implementation class, right? And within here, it's got this create tasks method. And we want this create task method to be able to be called from anywhere. You know, it could be called from an account object. It could be called from a controller in a class. It could be called from a batch class on a certain object or group of objects. I don't know. And, you know, maybe every single night we want to create tasks for a bunch of different objects. Well, basically what this allows us to do is dynamically, you know, basically we've abstracted this through the application class and the factory pattern enough that we can just call this one method everywhere, and I mean everywhere, and it will generate the right task creation call out based on the object type that you pass in here and the record IDs. So let me show you what I mean by that. All right, so this task service implementation class can be called literally by anywhere. I've got it being called from this abstract task creator controller that can be, you know, leveraged by a Lightning Web Component. But you could also call this from, like I said earlier, a batch class, a trigger, wherever. It really doesn't matter, but let's just check it out, right? So this is basically saying, okay, I want to generate a domain class by calling my application domain variable and leveraging the new instance method on the fflib application domain factory class. So let's I know this is kind of confusing. It's really not a great, super easy way that I can think of to make this much easier, but let me kind of explain this step by step. Let me bring this class back over here. So we've got our application domain. That's this class. It's calling the application domain variable here, right? And that application domain variable is of type fflib application domain factory. So because this variable is of type fflib application domain factory, the domain factory has a method called new instance where you can pass it record IDs to generate a new instance of a class, right? So, you know, we can just take a look at this. Basically what happens, more or less, I'm not going to take you through the whole ride, you know, down code lane here. But basically what happens is you pass your domain factory a set of IDs, and once it goes through the whole code tree, it's essentially going to return you a new instance of your your domain class based on the ID type that you sent to it, right? This set of IDs, they should only be of one object type, ideally. And then it's going to return to you based on the type of records that your IDs represent. Well, where'd you go? It's going to return to you a new domain instance based on that, right? So if those IDs are a caseF's object type, it's going to create a cases domain class. If those IDs are a contactS object type, it's going to create a contacts domain class. So right here, we are dynamically generating a domain class based on the ID's object type, right? We know nothing else at this moment in time. This is not a concrete class. We can basically generate any domain instance that we need at the time that this code runs, right? Same situation here. We are generating a new selector layer class based on the object type that we passed to it, right? And it works in the same way, where if I pass it a caseS object type, so this is our selector variable that we're looking at. If we pass it a caseS object type, we should get a case selector returned to us, etc., etc., etc. So again, not a concrete type. We're saying, all right, hey, at runtime, based on the object type I'm passing to you, please create a new selector layer class for me. Same kind of setup with the unit of work, although the unit of work instance is a little different. Really, the new instance methods for unit of work allow you to just change how the unit of work operates on the fly. So like I briefly mentioned this before, but if you needed to, you could change this here. So you could pass in a new grouping of object types if you needed to, just in case your order of insertion or updates are different than they are when you declared them in your application class over here. So unit of work gets more, I mean, it's the same kind of benefit, right? You've got the ability to generate new unit of works which, if you don't know what a unit of work is, basically it's just a way to handle your DML operations, your inserts, your updates, your blah, 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 whatever. And again, we'll go over that in the next video. Okay, so we're dynamically generating all these things at runtime, right? Your code, it's not creating a concrete class type of anything. We're dynamically generating all these different domains or domain selector unit of work layers at runtime based on what's passed in. And then we're doing a couple other things where we basically say, okay, if our object selector implements, this basically means if it implements the task selector interface, so our case selector implements the task selector interface, then we can call the method select records for tasks. Again, if you don't know how interfaces work, you've really got to take some time to go look into that. Basically, one of the biggest benefits of interfaces is that multiple classes, hundreds theoretically of classes, could implement an interface, right? And when you implement an interface, it requires you contractually to implement the methods in that interface. So for this particular task creator interface, it forces me to create an implementation of this method here, right? And then because your class now is of type task creator interface, you can, kind of in an abstract way initialize all these, figure out whether a class is of this type, initialize it, and then call these methods, right? Because you have to implement create tasks if you implement this task creator interface, right? So again, if you don't, interfaces, the concept of interfaces, polymorphism, things along those lines in object-oriented programming, you really got to understand those. I didn't put these in this tutorial series because I feel like enough people know them, but I might be wrong. So if enough people complain about the fact that I don't have videos covering those things, I might go back and cover them. But take the time to understand what they are. There's a lot of benefit in interfaces, in virtual classes, and things along those lines. And they're very important in the context of these conversations that we are having here. Okay, so back to it. We're figuring out, okay, our object selector that we have dynamically generated at runtime is of task selector interface. If it is, call the task selector select records for tasks and return that to this list. If it's not, call the selectSObject by ID method that all selector layers using the Apex Common library have. And if our object domain, this guy up here, is an instance of or it implements the task creator interface, then let's call the create task method that we have to implement in that class to basically allow it to compile, right? So yeah, I mean, as you can probably imagine here, even if this code seems a little confusing to you, through the use of this fflib application class, you get a lot of, dynamic runtime generation for things. You basically are using the factory pattern, which we discussed in the video prior to this one. And there's a lot of, as you can see, a lot of benefit to that. Because just like I stated in the last video, if you didn't use the factory pattern in the fflib application factory class and to kind of like determine what domain classes and selector classes you needed at runtime. If you wanted to implement the same concept of task creator, you'd have to send it in, do something like this, where you create a task creator method in your service factory, and you send it the S-object type, and then based on the object type you passed, if it was equal to a specific type, then you create, or then you'd call the create task method on the respective domain classes. So that's what these represent here. And you can imagine, you know, if you just got one or two of these, no big deal. But over time, you might find that you need this task creator to work in 30, 40 different scenarios. And this could grow astronomically, whereas the this one, it just won't grow. This is basically as abstract as you can make something. You'll never need to update this class, at least in the context of which domain class you call and which selector layer you call, things along those lines. So there's a whole lot of benefit to leveraging the application class in the Apex Common Library and truly, you know, using it as intended. So quite a bit of benefit. You can make your service layers pretty abstract and be able to work in, you know, a variety of scenarios. So all right, that is it, I think. Hopefully that has helped you all out there kind of grasp what this application, fflib application class, is kind of all about. Because I know it's a little confusing. It was kind of confusing for me in the beginning. If this doesn't, definitely make sure to check out either the GitHub wiki that goes over this considerably more in depth, every single method in this class. In this class, how to construct an application class, all those kind of things. It's all there in the GitHub wiki or the blog article that I've written for this. So feel free to check them out. And yeah, next episode we're going to go over the unit of work pattern. So stick around. There's more exciting, wonderful stuff to come. All right. I'll see you guys later.